So welcome, this is second lecture about surface tension, and today we are discuss the next important point from this concept, that is the relationship between surface energy and surface tension. Now in previous lecture we are discuss about the very important concept, that is the definition of surface tension and the definition of surface energy. We are remind the definition of surface tension and surface energy. What is surface tension? The tangential force acting per unit length. And what is surface energy? Now the potential energy per unit area, that is work per unit area also. Get it clear? Now after that, let's we discuss the new point from this chapter, that is important point from this chapter according to board examination and according to the all competitive exams. That is very important point. Let's we are started relation between surface energy and surface tension. Important point, relationship between surface energy and surface tension. Surface tension and surface energy. Okay, so what is the relationship between surface energy and surface tension? Such a relationship we are discussed with the help of and simple experiment. So we can performing an experiment, and with the help of this we are trying to discuss what is the relationship between surface energy and surface tension. So between this, now we are given a rectangular frame. We are trying to given the rectangular frame. Now imagine this is the rectangular frame. Okay, imagine that this is the rectangular frame, and this rectangular frame is represent P, Q, R, S. Now let's consider that this rectangular frame is made with wires. It means PQ is the wire, QR is the wire, SR is the wire, and PS is also wire. Both wires are connecting together and we get a frame. Now, but between this frame, now the QR wire whose length will be represent L. Imagine that the length of wire will be denoted by L. We are right here. Okay, this is the length of the wire. This QR wire is the slided wire without friction. It means the slided wire QR are easily moving towards the PS and easily moving outward the PS. This only one wire, that is QR. Okay, this only one wire is the slided wire between such a rectangular frame. Now after that, what happened? This rectangular frame is deep in the soap solution and take outside. Okay, just remember that this rectangular frame is directly deep into the soap solution and just take outside horizontally. So what happened here? So we know that when such a rectangular frame is directly deep into the soap solution, we are observe the same, the surface film will be produces. Surface film produces on the rectangular, between the rectangular frame PQRS. You get it clear? When such film will be produces, surface film produces between the rectangular frame PQRS. Now we know that, so when such a rectangular frame are directly connected with all the wires, now all the wires are experience the inward force due to the film. Okay. Let's imagine that a rectangular frame is deep into the soap solution and take outside. We are observe the same, the surface film produces. And when such surface film produces, such a surface film experience the inward force for all the wires. in the rectangular frame. But we know that between all the wires, only QR wire is the slided wire. So that's why through this film, now the slided wire QR is experience the inward force. Okay, this slided wire QR is experience the inward force. Why? Due to the film. Okay, because film is directly contact with 4 wires, and due to this, film directly experience, they produces inward force for that all the wires, but only QR wire experience the inward force because it is a slided wire. And if they moving towards the wire PS through the inward force F, now such a force will be denoted by, as per the definition of surface tension, we know that the definition of surface tension, T is equal to force per unit length. So the force will be denoted by F is equal to T into L. You get it clear? As per the definition of surface tension. Now when the wire QR experience the inward force F, as per the definition of surface tension, this inward force will be denoted by F is equal to T into twice of L. Why we write here 2? Now because when the slided wire QR experience the inward force, now the surface area of the film will be decreases. Now such surface area of the film is decreases between 2 sides. It means now this film having 2 surfaces is contact in air, and between 2 sides the surface area of the film will be decreases. It means 2 different sides. This is the front side and that is back side of the surface film. So that's why we can write here 2, because film having 2 surfaces. Get it clear? Now the total inward force experienced by the force F is equal to T into 2L. You remember this? Okay. Now after that we know that the total experience force, if the surface film produces, okay, if the surface film produces, in which direction the force is applied? The force is applied in the direction of towards the wire PS. Okay, so where the displacement produces of the wire QR? Exactly on the direction of force. It means the direction of force and the direction of displacement the wire is exactly same. So work does not done. Work cannot be produced. Okay. Now, but at this time, let's imagine that the slided wire QR is experience the same magnitude of exactly opposite force to the inverse. It means they experience the outward force of same magnitude, F is equal to T into 2L. The same opposite force experienced by the slided wire QR, and such opposite force will be denoted by F dash. Okay. And through this, the slided wire QR is moving from Q to, okay, this slided wire is moving from Q to Q dash and R to R dash due to the very small displacement dx. Okay, due to the very small displacement dx. So what happened here? Actually, the direction of force through the film is inward. But here the slided wire QR experience the outward force of same magnitude. It means the surface area of the film will be increases due to the very small displacement dx, and work has to be done. So as per the definition of work done, we know that work done is equal to force into displacement, and displacement will be denoted by dx, and outward force will be denoted by F dash. But we know that actually the same magnitude of force, so such magnitude will be denoted by F is equal to T into 2L. So put this value, okay, put this value in equation number 2. So what we get? Now we get the work done, dW is equal to force is represent T into 2L, and this is dx. Okay, T into 2L into dx. But between this expression, now this value of 2L into dx, okay, this value of 2L into dx, what is this? Now let's see, twice of L, that is 2 surfaces of the film. Now L is the length of the wire and dx is the displacement. It means length into breadth, so that is called area. So it means that 2L dx is indicate that increasing area of the film. This is the increasing area of the film, and this increasing area of the film will be denoted by dA. So it means that 2L dx is equal to the increasing area, and which is represent dA. So put this value from this equation. So what we get? Now we get the work done dW is equal to, so T becomes same, and 2L dx is called increasing surface area dA. So we get T into dA. So what is T for? Surface tension. So let's find out the value of surface tension. So surface tension T is equal to, we get dW upon dA. So what is meant by dW upon dA? What is the meaning of dW upon dA? So dW is the work and that is area, work per unit area, and we know that work per unit area means what? Potential energy per unit area. And what is meant by potential energy per unit area? So potential energy per unit area is called surface energy. Potential energy, you remember this, potential energy per unit area, so this is called surface energy per unit area. You get it clear? And this potential energy, what is this? The potential energy is the ability to do some work against the force. So if the work has to be done, such work done is restored in the form of energy. Such energy is called potential energy. It means potential energy is exactly equal to the work. So that's why work per unit area is also called surface energy. Okay, so it means dW upon dA, that is work per unit area, this is called surface energy, and T for surface tension. It means this equation is represents the relationship between surface energy and surface tension. Get it clear? What we given? We are given the rectangular frame of wire PQRS. So between the frame, QR is the slided wire without friction having length L. Okay, now when such frame is deep into the soap solution and take outside horizontally, we are observe the surface film produces, and due to the surface film, QR wire slided experience the inward force, and such force will be denoted by F is equal to T into twice of L. Why we write 2? Because film having two surfaces. Okay, now after that, when the slided wire QR experience the opposite force, outward force of same magnitude, now the wire will be moving from Q to Q dash and R to R dash, and due to the very small displacement dx, it means the surface area of the film will be increases, and when the surface area increases, so work has to be done, and such work done dW is equal to, as per the definition, force into displacement. So therefore dW is equal to force, their value T into 2L, so T into 2L and dx becomes same. So here 2L dx is the increasing surface area, and when we put the value of 2L dx, it means surface area. So definitely we get the third important equation, and such equation is represents the relationship between surface energy and surface tension. Get it clear, the concept of relationship between surface energy and surface tension? Okay, now let's discuss the next important concept from this chapter. That is very important concept from this chapter, and this concept is angle of contact. So let's start at the next concept, that is angle of contact. So but then before I can rub this. Okay, now let's discuss the next concept, important concept, angle of contact. Okay, the next concept is angle of contact, and which is represent theta. Angle of contact, important concept. So before we started the concept of angle of contact, we are trying to discuss their definition. So what is the definition of angle of contact? So I can write the definition of angle of contact. Okay, so initially we are write the definition, and then after we are trying to explain what is the actual concept of angle of contact. Let's see the definition. When the solid is contact with liquid, the angle between the tangent is drawn, the angle between the tangent is drawn on the free surface of liquid or the free surface of solid at the point of contact, measure inside the liquid is called angle of contact. Let's discuss this definition. Okay, now what is the definition? Let's see. When the solid is contact with liquid, now initial condition is when the solid is contact with liquid. So let's we are trying to given imagine that this is the this is solid, imagine that. Okay, and we know that the solid is contact with liquid. Okay, so this is the liquid. Okay, solid is contact with liquid. Now imagine that this is the point of contact where the solid and liquid are contacting together. So this is the point of contact, and between this point of contact we are draw the molecule. Okay, so imagine that this is molecule A. Okay, and such a molecule A is indicates that at this point the solid and liquid are contacting together. Okay, now their sphere of influence, the half sphere of influence in solid, this is solid and this is liquid. Okay, the small part of sphere of influence in liquid and the very small part of sphere of influence in air. You got it clear? So as per the definition, when the solid is contact with liquid, so solid and liquid are contacting together and the point of contact will be denoted by the molecule A. Next, angle between the tangent is drawn. Okay, angle between the tangent is drawn on the free surface of liquid or the free surface of solid at the point of contact, measure inside the liquid. Let's see here. Let's see. Imagine that this is the solid surface. Okay, this is solid surface, and on the solid surface we are given the drop of water. Imagine that. Okay, this is the drop of water. Okay, exactly the same condition. Now the solid and liquid are contacting together. When the solid is contact with liquid, angle between the tangent is drawn. Where we draw the tangent? Now at which point the solid and liquid both are contacting together. Okay, from this point we are trying to draw the tangent. Okay, such a tangent is also drawn on the free surface of liquid, and this is also drawn on the free surface of solid, otherwise free surface of air. It is not essential, but at the point of contact where the solid and liquid are contacting together, so from this point we are trying to draw the tangent. Okay, and when we trying to draw the tangent, now then after we are making an angle inside the liquid, so such angle is called angle of contact. Now let's remember this. This is very important. Okay, now now let's see, this is the point of contact where the solid and liquid both are contacting together. Now from this point of contact we are trying to draw the tangent. Let's see, this is the tangent. Okay, this is a tangent, so I can draw it. As per the definition, when the solid is contact with liquid, angle between the tangent is drawn. Where we draw the tangent? Tangent is drawn on the free surface of liquid or the free surface of solid or the free surface of air. It is not essential. But where we draw the tangent? At the point of contact. From, okay, the beginning of the tangent is at the point of contact. And when we draw the tangent, now we are making an angle. Okay, we are making an angle. Such angle we are measure inside the liquid. So such angle theta is called angle of contact. Get it clear? When the solid is contact with liquid, now angle between, in which the tangent is drawn on the free surface of liquid or the free surface of solid at the point of contact. Okay, where we draw the tangent? At the point of contact, and angle measure inside the liquid, such angle is called angle of contact. Get it clear, the definition? When the solid is contact with liquid, angle between the tangent is drawn on the free surface of liquid or the free surface of solid at the point of contact, measure inside the liquid. That is very important. Okay, when we draw the tangent, angle of contact is measured inside the liquid. So this is not angle of contact. Okay, this is not angle of contact. So angle of contact is measure inside the liquid. That is very important. Get it clear, the definition of angle of contact? Now let's see here. When the solid is exactly contact with liquid, the point of contact will be represents the molecule A. So this molecule A is represent that this point, the solid and liquid are contacting together. So when the solid and liquid contacting, now how many forces experienced by their point of contact? This concept is very important. Now let's observe here. Let's observe. Now when we draw the sphere of influence of molecule A, and molecule A indicates the solid and liquid are contacting together. So they are part of sphere of influence in solid, they are part of sphere of influence in air, and the part of sphere of influence in liquid. So when two or more molecules are contacting together, we know that the adhesive force experienced by the molecule A. Now the force of attraction between two molecules of different substance. Now the different substance molecules attracting, it means at the point of contact, the molecule A experience the adhesive force. Okay, molecule A experience the adhesive force. So imagine that this is the adhesive force. Now this adhesive force will be denoted by, this adhesive force will denoted by AP. Okay, so AP is the adhesive force. Get it clear? AP is the adhesive force. That is adhesive force. Now imagine that this molecule definitely contact with solid. Liquid and solid will be contacting. But if the liquid is mercury, we know that mercury does not contact with solid. You get it clear? It means two different substances do not contacting together. So definitely the molecule A is experience the cohesive force because the same substance molecules are attract. Two different substance molecule cannot attracting together. So with the help of this, molecule A many times experience the adhesive force. If the nature of liquid will be changed, so such molecule is experience the cohesive force inside the liquid. So this cohesive force will be denoted by AQ. So AQ is the force of cohesion, cohesive force. AP is the adhesive force. When the molecule A experience the cohesive force and adhesive force, definitely we are trying to draw the resultant force. Okay, so this is the resultant force is also experienced by the molecule A, and this resultant force will be denoted by AR. Get it clear? Now when the molecule A is present at the top, now this molecule A is also experience the gravitational force in downward direction. That is AG. So it means when the solid and liquid are contacting together, so their point of contact is experience the adhesive force, is experience many time cohesive force. So this AR is the resultant force between the cohesive force and adhesive force, and they definitely experience the gravitational force. So this amount of force experienced by the molecule when the solid and liquid are contacting together, and with the help of this we are trying to discuss their different cases of angle of contact. Let's begin the cases of angle of contact. So can I rub this? That is very important. Cases of angle of contact. Cases of angle of contact, and between this we are discussed the first important case. Okay, the first case for acute angle of contact. Okay, for acute angle of contact. The first case we have discussed, the angle of contact is acute. So let's trying to discuss the concept of angle of contact, and between this we are discuss the angle of contact is acute. So we can draw the diagram, and with the help of this we are trying to discuss. Now we are given a solid. So imagine that this is solid, and just we are take a liquid. This is second container, and between this second container we are given a liquid. Okay, this is a liquid. We are take the molecule, because this molecule is indicates where the solid and liquid are contacting together. So this is our molecule. Okay, so now this is our molecule A. This is our molecule A. Okay, this is the molecule, and such molecule is represents the solid and liquid are contacting together. Let's discuss the first case for acute angle of contact. Now when the solid is contacting with liquid, and imagine that the liquid is kerosene. Okay, the liquid is kerosene. It is an oily liquid. It is not a pure water. It is not a mercury. It is kerosene. Imagine that. When the kerosene is contact with solid, can you know that kerosene oily liquid is completely weight to the solid? No. Okay, pure water, we know that pure water totally and completely weight to the solid when they are contacting. But when the solid is contact with kerosene oily liquid, so oily liquids are partly weight to the solid. Now let's you remember that when the solid is contact with liquid and the liquid is kerosene, so kerosene partly weight to the solid. Partly weight to the solid. It means partly two different substances are contacting together. Okay, partly two different substances are contacting together. It means what? When two different substances are contacting together, so molecule A is experience the adhesive force, and which is greater. So now partly two different substances are contacting together. When the solid is contacting with liquid and the liquid is kerosene, so we know that kerosene partly weight to the solid. It means adhesive force is greater than cohesive force. Okay, it means adhesive force is greater than cohesive force. So adhesive force will be denoted by AP and cohesive force will be denoted by AQ. So adhesive force is greater and cohesive force will be smaller. Adhesive force is greater than cohesive force. Get it clear? So it means that the resultant force is also towards the solid because it will be higher. Okay, so this is the resultant force. Get it clear? Now when the solid is contacted with liquid and liquid is kerosene, we know that kerosene partly weight to the solid. It means partly two different substances are contacting together. It means adhesive force is greater than cohesive force, and the resultant force is also towards the solid due to the greater of adhesive force. Now after that what happened? Actually, for the previous condition, we had discussed the same when the molecules are present on the free surface of liquid, and finally all the molecules are deep into the liquid because all the molecules are experience the net resultant downward cohesive force. It means when the molecule, let's see here, we draw the same concept. This is the liquid, and our third liquid molecule will be here on the free surface of liquid. There half sphere of influence in air and half sphere of influence in water, but the molecules see well deep into the liquid because they experience the net resultant downward cohesive force. Why? Because the density of air is very smaller than the density of water. Density of water will be large, and that's why the adhesive force between air and liquid will be neglected, and only the cohesive force is experienced by the molecule, and finally they deep into the liquid. It means what? When the adhesive force is strong, imagine that. So when the adhesive force is effective on the molecule, so molecule just trying to keep vertically upward, it will just normally creeps vertically upward when the adhesive force is strong. But here adhesive force is neglected, that's why molecule creeps normally vertically downward due to the net resultant downward cohesive force. So between this concept, you just remember that when the cohesive force is effective, molecule deep into the liquid, and when the adhesive force is effective, just molecule trying to creep vertically upward normally. Okay. So now here at this condition, the adhesive force is greater than cohesive force. So it means molecule does not deep into the liquid. So molecule normally creeps vertically upward. Okay, molecule normally creeps vertically upward. What it means? It means, let's see, this is solid. Okay, this is liquid. This is liquid. Now, initially the molecule will be here. Okay, initially the molecule will be here. But the adhesive force is greater than cohesive force, and when the adhesive force is strong, now molecule normally creeps vertically upward. Okay, molecule normally creeps vertically upward because adhesive force is strong, and when the cohesive force is strong, so molecule creeps vertically downward because they experience the net resultant downward cohesive force. But here the adhesive force is strong, it means molecule normally creeps vertically upward and they will be present here. Okay, the molecule will be present here, and when the molecule creeps vertically upward, now let's observe the same. The point of contact is normally concave. The point of contact between solid and liquid will be changed, and the point of contact will be concave. You get it clear? And after that, when we draw the tangent, okay, after that, when we draw the tangent at the point of contact, so we are measure the angle theta between the liquid, and this angle theta is acute. You get it clear? So this is very important. Now when the adhesive force is greater than cohesive force, we know that after this the molecule normally creeps vertically upward. Okay, molecules normally creep vertically upward and it will be reaches here, and the point of contact will be changed, and the point of contact will be concave. The concave point of contact. Okay, the point of contact will be concave that type, because it will be shifted vertically upward. And if the point of contact is concave, so then after we are trying to draw the tangent, and when we draw the tangent at the point of contact, let's see. So we are draw the tangent at the point of contact. So after that we are measure the angle theta between the liquid, and this angle theta is called angle of contact. Get it clear? Okay, so this is our first case, the acute angle of contact. For acute angle of contact, we have draw the diagram correctly. Now this is adhesive force, this is resultant force, this is the cohesive force, and we are drawing the tangent. This is the point of contact. This is a tangent. Tangent will be denoted by AT. Okay, and when we draw the tangent, the angle of contact between the liquid is acute. Okay, this is our first case. Get it clear? When the solid is contact with liquid and the liquid is kerosene, so kerosene partly weight to the solid, it means adhesive force is greater than cohesive force, and that's why the resultant force lies along the adhesive force, towards the adhesive force, and molecule normally creeps vertically upward. That's why the point of contact is concave, and when we draw the tangent at the point of contact, so the angle of contact within the liquid is acute. So this is our first case about acute angle of contact. Get it clear? Okay, let's see the next concept. Next concept, for obtuse angle of contact. The angle of contact is obtuse, it means greater than 90 degree. The diagram will be same. The diagram is exactly same. Now let's see the diagram. So this is the point of contact. This is the point of contact between solid and liquid are contacting together. So this is molecule A, and molecule A, it shows that the solid and liquid both are contacting together. Okay, both are contacting together. Now at this condition, imagine that the solid is contact with liquid, but the liquid is mercury. We know that mercury does not weight to the solid. It means mercury does not contact with solid. Okay, two different substances are contacting. Definitely two different substances are contacting together, but mercury does not weight to the solid. It means what? It means, now it means cohesive force is greater and adhesive force will be smaller. So cohesive force is greater than adhesive force. Okay, why? Because when the solid is contacting with liquid, the liquid is mercury, and mercury does not weight to the solid. It means two different substances are separate. Definitely they are contacting, but it does not weight. It means two different substances do not attract with each other. They does not contact with each other. So that's why the cohesive force AQ is greater than the adhesive force AP. Then the resultant force is also towards the cohesive force, and resultant force will be denoted by AR. So what happens when the cohesive force is effective? Now when the adhesive force is effective, molecule normally creeps vertically upward, and when the cohesive force is effective, so molecule normally creeps vertically downward, and the point of contact is convex. That is very important. So then after, this molecule is normally shifted vertically downward because the cohesive force is strong as compared to the adhesive force. And between this, let's see here, this is the solid and this is liquid, both are contacting together. Okay, both are contacting. Initially the molecule will be here. Now the cohesive force is greater than adhesive force. Okay, so cohesive force is greater than adhesive force. So this is cohesive force and this is adhesive force. So cohesive force is greater than adhesive force. Now the resultant force is also towards the cohesive force, and due to this, molecule normally creeps vertically downward. The molecule will be here. When the molecule creeps vertically downward, now the point of contact will be convex. Let's see, the point of contact will be convex. And after that, when we draw the tangent, let's see, when we draw the tangent, now the angle of contact between the liquid is obtuse, is greater than 90 degree. It is very important. Okay. Now the second case, when the solid is contacted with liquid and liquid is mercury, we know that mercury does not weight to the solid. It means cohesive force is greater than adhesive force, and resultant force is also towards the cohesive force, and molecule normally creeps vertically downward. And when the molecule normally creeps vertically downward, the point of contact will be convex, and when we draw the tangent, the angle of contact is obtuse, greater than 90 degree. This is our second case. That is very important second case. Now the accurate diagram you are draw with the help of our government textbook. Okay. Now definitely clear. Third important case for zero angle of contact. Zero angle of contact. The angle of contact will be 0. Okay, the angle of contact will be 0. Now let's imagine that this is solid, okay, and this is liquid. Solid and liquid both are contacting together. Okay, the solid and liquid are contacting together. This is the solid. Solid and liquid are contacting. The point of contact is here. So we are draw the molecule. So this is molecule A. This is our molecule A. And molecule A we are draw at the point of contact where the solid and liquid are exactly contacting together. Now when the solid is contact with liquid, between third case, let's imagine that the liquid is pure water. Okay, liquid is pure water, and we know that the pure water totally and completely weight to the solid. Completely weights to the solid. It means that 100% to different substance are contacting together. It means adhesive force is very strong. Okay, so adhesive force AP on the molecule A is very strong, and as compared to the adhesive force, so cohesive force will be neglected because pure water totally and completely weight to the solid. So that's why adhesive force is very strong, and as compared to the adhesive force, so cohesive force will be neglected. It means that the resultant force between cohesive force and adhesive force, so the resultant force is also along the adhesive force because the cohesive force will be neglected. And after that, when we draw the tangent, okay, so this tangent is exactly at the point of contact is parallel to the solid and liquid will contacting together. And when we draw the tangent, okay, this is the tangent. So when we making an angle, so definitely the angle of contact between pure water and solid is 0. This is very easy and simple case. First case about acute angle, second case about obtuse angle, and third case about 0 angle of contact. And one again case will be remaining. So fourth case, you get it clear? When the solid is contact with pure water, so pure water is totally weights to the solid. That's why the adhesive force is very strong, and as compared to the adhesive force, the cohesive force will be neglected. So that's why the resultant force is also along the adhesive force. And when we draw the tangent, now tangent is exactly parallel to the point of contact, and that's why the angle of contact between solid and pure water will be 0. You get it clear? Every time you remember that, every time when we draw the tangent, so tangent is perpendicular to the resultant force. Okay, sorry, resultant force and tangent are right angle with each other. So due to this, definitely we are trying to measure the angle of contact. This is the condition. Okay, now this is the accuracy for that diagram. Now here the angle of contact will be 0. Get it clear? Now the last case, fourth case, about the angle of contact. The angle of contact is 90 degree. Okay, 90 degree angle of contact. When the angle of contact is 90 degree, let's draw the diagram, and with the help of this we are trying to discuss. The angle of contact is 90. Okay, imagine that this is solid and this is liquid, both are contacting together. This is the liquid. Now this is the point of contact between the solid and liquid. Clear? When the solid is contact with liquid, so imagine that the liquid is hypothetical. Hypothetical means imaginary, considered liquid. When the solid is contact with hypothetical liquid, I don't know that which type of liquid will be there. So that is hypothetical liquid. Okay, when the solid is contact with hypothetical liquid, now after that the cohesive force between the molecule A, okay, the cohesive force AQ is exactly 45 degree. Okay, the cohesive force AQ is exactly 45 degree with the surface, with the point of contact. You got it clear? Definitely they experience the adhesive force AP. Okay, so this is the resultant force AR. Get it clear? Now this is the resultant force. You get it clear? Sorry. So cohesive force is exactly 45 degree. It means the resultant force is also along the point of contact. So this is the resultant force. And when we draw the tangent, so tangent is exactly tangential to the free surface of liquid. So when we draw the tangent, so we are making an angle within the liquid is 90 degree. Okay, I don't know that what happened between this case, because the liquid is hypothetical. According to kerosene, we know that kerosene partly weight to the solid, that's why adhesive force is strong and cohesive force will be weak. When the solid is contact with mercury, we know that mercury does not weight to the solid, so adhesive force is cohesive force is greater than adhesive force. And after that we know that the pure water completely and strongly weight to the solid, that's why the adhesive force is very strong, and as compared to the adhesive force, the cohesive force will be neglected. But here the liquid is hypothetical. Okay, the liquid is hypothetical. When the solid is contact with hypothetical liquid, the cohesive force is exactly 45 degree. Okay, exactly 45 degree. Imagine that the solid is contact with liquid. Okay, in which type of liquid? Hypothetical liquid, imaginary liquid. But when the solid is contact with that type liquid, their cohesive force is exactly 45 degree with the point of contact. Okay, so then after the angle of contact is 90 degree. So this is fourth case about angle of contact. That is very important concept according to the surface tension. Can you get the definition of angle of contact? When the solid is contact with liquid, angle between the tangent is drawn on the free surface of liquid or the free surface of solid at the point of contact, measure inside the liquid. Okay, so this is called angle of contact, and they are all important cases about acute angle, about obtuse angle, about zero angle, and about 90 degree angle. Get it clear?